Hi guys, can you all hear me fine? All right, perfect. Thanks for spending your Friday evening with us today. Appreciate it. Okay, so pretty informal talk actually. No rules as such. You can raise your hand to ask questions at any point. I will also try to end a bit early for some Q&A at the end. Lastly, you can also approach me after the session ends to chat. And first of two disclaimers, I'm a backend engineer. My slides are super ugly. I apologize, but hopefully the content makes sense. All right, just want to understand a little bit about you guys as well. So raise your hand if you are a computing or computer engineering student. Okay, interesting. What about the others, the non-computing students? Diverse group, all right. Hi. And how many of you are undergrads? Okay, almost everyone. Any masters or PhD students? All right, hi there. All right, any teachers, professors here as well? Okay, no one, not invited. All right, anyone who is already graduated and working, not as a teacher, software engineers in the room? All right, hi, designers. Nice, I see you. PM, any PMs in the room? Everything else? All right, cool. I guess I can say mostly whatever I want and no one can correct me. All right, so some light definitions first. So when I use the word hacker, I don't mean a security threat always, but more of a problem solver. And the kind of traits that I'm going for in a hacker is curiosity, creative problem solving really. I'll be giving some examples of what I mean later. And yeah, so the question I would like to pose to all of you is, what if we could all think like hackers at work? Yeah. Now, mindset. Specifically, I'm aiming for the way that you approach problems. And lastly, by work, I mean the traditional workplace, not working on your assignments. All right, so this is an example of traditional problem solving at the workplace. So basically, you see a problem, you make a request, you go to your manager says, hey, we will slot it into this project if it's even approved. So approval itself might take a few months. By the time that you get to work on it, the problem no longer exists. ChatGPT has a plugin for it. Eventually, then there is the delivery stage. So the typical cycle duration from my experience, and you guys can Google it, is about 3 to 6 months, which is obviously a bit on the longer side. Sometimes by then, the problem does not even exist anymore. The question is, why does it take so long? Anyone has any answers for this? You can shout it out. Okay, so generally speaking, the reason it takes so long is a few things. People are shy. People have other things to do. They have KPIs to meet. There's also other issues like you don't want to break the system, right? That's a fear that people consistently have. Let's say you're working at a bank. You are pretty afraid to change the DBS Payla app, even though you kind of know it sucks, right? You don't want to break something. So there is some hesitation in approaching problems in this way and trying to fix it yourself. All right, so what's hacker style problem solving? So it's quite simple. Basically, you see a problem, and then you go a little bit rogue. You try to build a prototype for it, and then you do a demo, and then you iterate over it. So in a way, you're asking for forgiveness and not for permission. Why do I say this? If you go to your boss today and you say, I want to work on this cool ChatGPT thing, and it doesn't really align with the team's KPIs, he might be cynical about it. But at the same time, if you prove that, hey, I built this over a weekend, this is how it works, it's really simple, we can start using it right away, it has a very different impact. And then generally speaking, no one's going to scold you if you say that I worked on it over the weekend and things like that. So I think that's the difference between normal problem solving and hacker-style problem solving. All right, so the key benefits, some of them are quite obvious. Much faster feedback loop, cost savings. I'll be giving some solid examples of this later. Empowered and resourceful teams. So in a certain, let's say a lot of people here might be aiming to work at FANG, right? That might be, or it was a big thing when I was graduating, not sure about it now. But one of the advantages of those companies is that they have a lot of resources. They pay for all the tools you want. Jira la, Asana la, Slack la, O365, things like that. And actually that may actually not be very good for you because you just pay to solve problems as opposed to look for a creative solution yourself. So cost savings can be actually a very big part of hacker-style problem solving. Empowered, resourceful teams, teams that lean towards action and try to solve problems themselves. Culture of experimentation as well, and of course, a whole bunch of other things. All right, so what exactly is hacking at the workplace about? So it's not about breaking into systems, it's about breaking assumptions. So it's about creative problem solving within certain constraints of your organization, building quick, scrappy prototypes to test ideas before putting in very large investments. Anyways, in the age of AI, and the next talk will talk more about this, it's much cheaper and faster to experiment as well. And this industry changes so fast, right? If I think about my time, I only graduated about 7 years ago. 6 years ago, if you round down. And things are very different then. Back then, we didn't have like OpenAI, ChatGPT to code with and things like that. It was slower, but still much faster than 10 years ago and so on. So it's generally much easier to hack. And the fact that if you guys are computing students majorly, right, you're able to really understand what's happening and make changes and iterate very quickly. So what is hacking about? Curiosity, bias for action, and respect for guardrails where needed. Yeah. Okay, so why hacking matters? Formal processes, like I earlier described, they are designed for stability. The system just wants to work. Everyone is afraid to break something, not really for discovery. Innovation happens when someone says, what if we tried this instead? Or last weekend I was working on this, check it out. Generally speaking, people are really excited about these things. So hacking fills a gap between an idea and approval, and it encourages ownership. People are more empowered to solve problems themselves. Okay, so here are some good real-life examples of problem solving at work that led to an actual product or company that came out of it. One of it is Gmail. So one of the engineers at Google, Paul, I shall not try to pronounce his last name, during Google's famous 20% time, came up with the idea for Gmail. Slack as well, which was an internal chat tool at a different company. Facebook like button, which was built at a hackathon by some Facebook engineers. Twitter, which Jack Dorsey was experimenting with at a different company. And even AWS, which was not meant to be monetized initially. They were trying to solve problems within the company itself. All right, so some examples inspired by my own experiences at the workplace as well. So disclaimer, treat these examples as fake examples inspired by my real life experiences. No intellectual property infringement intended. And of course, I would like to thank my former and current colleagues and managers for providing a supportive environment to experiment and for working together with me. I think this is easy to take for granted, but depending on which kind of organization you're in, it can be quite difficult, and you have to try to play with the system. All right, so the first problem that I would like to touch on is tech support. So this is something that is very, very common in the software engineering industry, right? At some point or the other, you have to do tech support of some form. So in one of the companies I used to work at, basically this was the problem. It's a delivery company, I won't say which. We had warehouse operations and drivers. They had no easy way to raise urgent tech support issues. So what did they used to do? They used to go to a Slack channel. Slack channel had 20,000 members, literally. They would go inside the channel, add channel, which tags everyone 24/7, and say, I need help, I can't scan parcels anymore. And even though we only deliver parcels between 9 a.m. and 9 p.m., parcels are being sorted 24/7. So if you can't scan parcels the previous night, parcels will not be delivered the next day. So it's actually kind of a critical thing that stops the entire company from moving, right? And then what do? It's 4 a.m., no one responds. They start calling the CTO. CTO doesn't pick up, they start calling the VP of engineering. So basically, it's pretty chaotic. And you guys might be wondering, why not pay for something, right? There's elegant tools out there, there's PagerDuty and so on. All right, so paid solution, PagerDuty or Ops Genie. The cost is about 5 to 10K USD per month for the number of engineers that we had. So what are the main downsides other than the cost? One more platform to manage, hard to move out of a platform. So the thing is, once people get used to using a certain tool, right, it's very difficult to get them to change. Once a company pays for Slack, try migrating to GChat or something, and everyone's going to hate you. It's going to be really, really unpopular. So one of the things that people who are interested in like founding a company should think about is that when you guys pay for any tools, it's impossible to move out of it. Yeah, because people really hate change, hate moving to new systems. So it's something to consider before you start paying for a tool, whether you can build it yourself. Yeah. Of course, along with this, you're paying for it, and you still need to train users to use it anyway. It's a new tool after all, right? Okay, so here's our solution, which is really quite simple. It's a Slack bot. The way it works is we created a very simple Slack bot. It shows a simple form in the same channel that users were filing tickets. So they go to the tech support channel and file tickets previously. Now they have to do a / command, which pops up with a form. Based on the urgency, right, we would either tag engineers if it's a low priority issue, or start calling them, similar to PagerDuty if it's a very high priority issue. So I used Jira literally as the database. So we didn't even have a database. The backend is just Jira because you can create a ticket and it's similar to how a database functions. And we built a custom service to integrate with a voice API for calling and acknowledging issues. So what do I mean by this? I have a diagram. All right, so this is a very ugly diagram about how this tech support Slack bot works. So basically, you have a user who was previously using Slack. They continue to use Slack to file an issue. And then on the back end, I have a Python app which is specifically listening to this Slack channel. So what I do is I return a response, which is a form that Slack dynamically loads. And then once the user decides to submit the Slack message through this bot, what happens is that this goes to the Python app, which calls the Jira server. And then basically you fill in the fields similar to typing it manually on Jira. And then eventually I also have a Go application, which is doing the rostering and calling. What do I mean by that? A company starts to have more complicated things, right? People go on leave, people are on MC, people want to swap because they, for whatever reason, were busy one week and things like that. So we do need more functionality than just going default round robin and calling every single person. So that's what the job of the Go application was, to do this rostering and calling. So it's very simple, like how you guys imagine. You get a phone call and it says, press 1 to acknowledge, 2 to decline, and so on. So based on that, it will respond accordingly. And really very, very simple. There's no database in this entire thing. So the Jira server, it gets the webhooks from the user's phone call through the voice API. So as you can see, right, it's a super simple, lightweight system that can be powered by your laptop. It's not something that takes months and months of dev effort. It's something that was built over the course of a couple of days. And this was without AI as well. Yeah. Okay, so what was the impact of this thing? So this became the new way for ops to file tickets of varying urgency. Very, very simple. And because people started using it, right, because of the traction, teams that are not engineering based also decided that they wanted to use the tool. For example, for ops, if there's any customer support tickets, they were like, hey, this is honestly the most simple, no-brainer way to do something. We can have very simple translation within Slack itself to translate to Bahasa Indonesia and different languages that people are using. And it's free, does the job. Yeah, so it also saves the company 1 full-time engineer worth of money per year, which is quite a lot. And lastly, the impact is really on ops, where previously the time to acknowledge used to be around 2 hours. It became 5 minutes. Because no choice, right? Your phone keeps ringing and ringing until you acknowledge. So I'm sorry to those engineers for that. And the time to response became from 2 days to 2 hours. Yeah. All right. This is the second thing I would like to talk about. It's a bit more technical, but I will still try to keep it simple. Feel free to raise your hand if you have any questions. So this is regarding database migration automation, specifically for MySQL. So what do I mean by database migrations? Alter table, blah, 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 add column, blah, 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 something like that. So before this, in order to appreciate what we are going to talk about, I would like to talk a little bit about the history of database migrations. Yeah. Okay, so this is the very ugly slide on history of DB migration tooling. So in the early days, right, have most of you guys taken a database class, Intro to Databases? Is it called 2205 still? Was it 2205? The number changed, 2102. Ah, yes, okay, no, my memory failed. Yeah, okay, it's 2102, all right. So you guys know that in database tables, when you want to do schema changes, it can sometimes be a dangerous operation, especially if you have a live application. So how was it done in the early days? Basically, the company would announce, hey, from 1 a.m. to 4 a.m., Payla is not going to be available because we have a database migration at DBS. That was the old school way of doing things. And obviously, some companies still have to do it this way for whatever reason. Yeah, so that's how migrations were previously done with downtime, basically. But as you guys know, nowadays, downtime is not acceptable for most applications, right? I think it's pretty much only in the banking industry or maybe like stocks and things like that where there is downtime. Generally speaking, Facebook doesn't have downtime, Instagram doesn't have downtime, TikTok doesn't have downtime, ChatGPT doesn't have downtime. So this is no longer acceptable. So the next generation of tooling was using migration scripts where you actually commit the SQL file of changes that you're going to operate. That way you can sync up different environments. So scripts are basically tracked in version control, but they still rely on alter table directly. So what are some examples of this? Flyway and Liquibase. I'm sure you guys might have used something like that. But basically the concept is that instead of going into your database and running the alter command, you write and control it in your version history. And that way you can play it back in different environments. You can have some automated settings like every time there's a change in QA, run it automatically. If it fails, then don't run in production. If it passes, then run. So that way you are able to basically replay and remake the database if needed. Yeah. Okay, so that was the old way. After that came online schema change tools. So this could be paid. Basically, the way they work is they use triggers to sync data between old tables and new tables. So what do I mean by that? A database trigger is very, very simple. It's like saying when something happens to table A, do the same thing on table B as well. So that way, right, you can do a database migration by swapping the tables at the end. So you have table A, which is your original table. Table B has a new column. What you can do is you can create a new table that has a new column and copy data over. But then what about the new writes? That's where the trigger comes in. So you have a database trigger, which basically every time there's an insert also happens here. Every time there's an update also happens here. So there's a very obvious downside of this approach. And the downside is that for every write, 2 writes need to happen. And if you have database lag, the lag is just going to be infinite, and your original database will actually never catch up. Your new table will never have the chance to catch up because of the number of writes that are happening. Yeah, so your table just keeps getting slower and slower when the migration is happening. So some examples include Pacona PT online schema change. I think some of them could be paid and some are open source and free. Okay, lots of talking. Now we have the modern tooling. One example is basically cloud native migration tools. So they use binlog or online copy techniques. So what do I mean by that? So the MySQL database, right, it actually generates a binary log. It's almost like a video playback. So by reading the logs and playing it back, right, you can recreate the entire database. So it's not a snapshot of the database, that's different. It's every single query that was ever run on a particular table. So by reading the bin log directly, you're actually not introducing load on the database, and you're not slowing down that table from having writes. So that's the magical part about like these more modern toolings. Yeah. So it's fully online. It zero downtime. You can observe the status. You can actually throttle it if you're introducing too much load. And cutovers are safe. What does cutover mean? Cutover is basically the step where you rename the old table to the new table to the old table. Yeah, so this is obviously done in an atomic operation. It takes about 1 millisecond or so. And to the users, there's basically no downtime. Yeah. So what are some examples of this? Ghost, which I'm going to zoom into. Vitesse online DDL from MySQL 8. Okay, so now that we already have this magical tooling, right, why do we need to build on top of it? So even though you have these tools, the migrations are still manual, slow, and dangerous to run. This is because you still need a database engineer to do some checks. You need to check if there's enough disk space. Why? When you're doing such a migration, right, basically you need at least twice as much space because you have 2 tables of the same size at any point in time, one with the new column, and then you swap the names. Yeah. You need to run the query, you need to check the syntax, you need to monitor the progress, and you need to perform the cutover. And of course, the person who's performing this, right, if they make any mistakes, you might be losing production data. So obviously, only the most senior database engineer in the company can run this ops. This guy goes on leave, the company can cannot live stress-free. All right, so here was the existing process even after the latest tooling was introduced. Yeah, so I specifically am referring to Ghost, which is GitHub online schema tool. It's great, open source, but it does have some issues. So an engineer needs to ensure sufficient disk space needed for the migration. Engineer needs to verify whether the syntax of the migration query is correct. Imagine if you run the wrong syntax or something like that. Yeah, or the syntax is valid, but you add a wrong column, remove a column accidentally, quite dangerous. Of course, the same engineer, they also have to monitor the migration. They have to keep informing the stakeholders, which are generally backend engineers, of the progress of this. They have to perform the cutover step, which is when you rename the tables. Okay, so before I jump into the solution, I just want to very briefly touch how Ghost works, because I do think it's an engineering marvel as well. So kudos to the GitHub team, hire me. It creates a Ghost table, which is basically a copy of the table with the new schema. So the old one is missing a column. The new one has this new column as well. This is called the Ghost table. It then replays the row changes from the binary logs. It's really like replaying a video. It's not just taking a snapshot and forcing it in. It's really doing every single thing that happened from any inserts and updates, basically the DDL related steps. Yeah. Of course, the select you don't need to do, so it's the insert and the updates, right? Yeah. So it does not use triggers, which is magical, because in a lot of database setups, right, you have a master-slave architecture and things like that. If you have a lag on the master, right, every single thing is going to lag. Your reads are going to lag for like days at a time. So this is something that was really quite magical when it first came out. Once it's caught up, it renames the old and new tables. This is what I mean when I say cutover. And yeah, the migration is complete. All of this happens while your production DB was online all the way. Okay, so given the problems that I described earlier, where you still needed senior database engineers to be monitoring the progress of everything, the thing that we built on top was some automation. There was a couple of parts to it. The first part is a Jira. It's also called Jira Service Management. It's also called Jira Service Desk. They're all the same. Basically, it's a Jira form. It provides a UI for anyone to request a migration. By anyone, I'm referring to engineering teams, right? You don't want like your designer to dictate your database schema. So it's any backend engineers who are familiar with databases to request a migration. What it will do is it will run all the necessary checks. Is there enough disk space? Is the query syntax correct? And then it provides updates on the Jira ticket. So even before you proceed, right, if the query syntax is wrong, there is no need to bother the database engineer to begin with. He should only start to get involved when it's the very low-level step of checking whether the correct column is being added, whether the type is correct, and so on. And then eventually, if there is approval being given from whoever you want, normally, let's say it's the staff engineer and the database engineer. Once they approve that this change kind of makes sense, then only it will run the query while providing updates on the Jira ticket. 50% done, 8 hours left, and so on. Lastly, this process is fault tolerant. So if you are using a Kubernetes environment, you guys would understand that a pod can restart at any point in time. So if that happens and your migration is being run, all your effort is wasted and you have to restart. It's basically like when you guys are running some code on your laptop, right? You don't want it to like sleep. Then your Telegram bot will shut down. So it's the same concept. So it's fault tolerant so that even if Kubernetes restarts the pod, the migration would not stop. Okay, so how does it work exactly? So the user files a Jira ticket. There is an approval step. So an engineering manager, lead DB engineer approves the ticket. After that, Jira sends a webhook to Go microservice. Then the Go microservice does a few things. So you will check if there's disk space. You will resize the disk if there's sufficient space, which is an additional nice step because previously someone had to do it manually. After resizing, it runs a no-op migration, which basically is a dry run of the query syntax without actually running the actual thing. Lastly, a cube job spins up, which is why I was referring to fault tolerant earlier. It doesn't happen in the pod, but a job spins up. And basically for the job, right, you're guaranteed that the job is not going to restart for whatever reason, unlike the pod. And then basically the database migration is run in the kube job. From the kube job, webhooks are sent to the Go microservice and in return Jira to update the ticket status. And lastly, the database admin, all they have to do is verify the migration and manually perform the cutover step. So instead of doing all these 10 different things manually earlier, which leads to a lot of frustration, all they have to do is, do I really want to rename the tables? Does everything look correct? More of a sanity check instead. Yeah. And of course, by the way, the cutover step can also be done manually, but I wasn't that confident in my work. I was like, yeah, you all manually check lah. Yeah. Okay, so another ugly diagram. Basically, backend engineer, someone who's familiar with the schema, they want to request a database change. So they would fill up a Jira service management form. There are webhooks being sent to a Go microservice. The Go microservice will do certain checks like I described earlier. And lastly, if they decide to proceed, a kube job is fired off, and this does all the heavy lifting and makes the changes to the DB. Finally, the actor can choose to rename the tables if everything happened correctly. Okay, so what are the results of what we built here? So now, firstly, UI, engineers now have a UI to request database migrations. You guys would be surprised. I know, like, as a student, I was definitely like CLI all the way. But in a production environment, when you make mistakes, you copy paste wrongly, you have different shells and things like that. Actually, having a UI for people who know what they're doing and don't know what they're doing really makes things much easier. Yeah. So migrations only run if all the requirements are met. There is no need for constant monitoring. You can literally go to sleep because there's nothing dangerous happening. And if you wake up and the job is done, you can choose to rename the tables. So finally, about over 300 migrations were done automatically, saving about 1,000 plus engineering hours on average. Okay, do you guys need like a 1-minute break before I move on to the next one? Okay, this guy said no, so we shall proceed. Okay. I think this is the last topic actually. So I would like to touch a little bit on fraud tooling. So here was the problem. So you are working at an unknown delivery company as well. And what you realize is that the drivers based in various countries around the world underpaid, extremely smart at performing scams. So they will find whatever exploits in your system, right? They're probably the best white hat hackers, I guess. Or actually not white hat, they're just hackers. They will find all these ways to perform scams. And I would like to touch on a very specific one, which is called the cash on delivery scam. So this is the reason that you guys read in the newspapers when people are delivering parcels to your house, right? You tell your parents, don't accept the parcel if it's a cash on delivery, because maybe the driver is just trying to trick with a fake parcel and get the money. This is something along the lines as well. So for this, you need two fraudsters, two crooks. One is a delivery driver, and one of them is a fake recipient. Basically, the way it works is this. When a delivery company performs a delivery, and it's cash on delivery, right? The way it works is that I am the Ninja Van driver. Sorry, I am a driver. Okay, I'm a driver delivering iPhones. I go to a customer. I give him the iPhone. The customer gives me $1,000 because it's a cash on delivery, remember? Ninja Van now owes Amazon $1,000. Okay, deduct from my balance. And then Ninja Van goes and collects $1,000 from the driver. So do you get it? If I have a lot of money, I can just run away, never pay Ninja Van. But Ninja Van or any other delivery company will be scammed. So basically, this is the way it happens. So the way, if you're really quite smart, right, you know how to make very simple API calls and things like that. You don't even have to deliver real parcels. I can claim to deliver 1,000 phones. I know the guy who is running this store. I work with him to deliver 1,000 empty packages. Now Ninja Van owes $1 million to some company. Yeah, that's basically the way it works, and it's real, sorry. Yeah, so this is basically the modus operandi of this particular type of fraud. And of course, there's a whole bunch of different ones. This is the one that I will try to recommend a solution for. So the previous solution, run after criminals. Try doing that in Indonesia, which has like many thousands of islands and people have different identities and things like that. Basically not possible, right? Your money is lost. Okay, so here's our solution. Very, very simple. I guess inspired by COVID. You quarantine the webhooks. So basically the way that a delivery company informs a marketplace like Shopee that a parcel is delivered is of course going to be a webhook, right? And there's very, very strict SLAs on this. So basically, if a parcel has been left outside your doorstep, you want to know immediately so that you can ask your mom or dad to pick up the parcel from in front of the door, right? So there's very strict SLAs on such delivery notification webhooks. So the delivery company informs the marketplace. Marketplace sends you a push notification or SMS, whatever. That's how it works. So it's kind of a mission critical thing with very strict SLAs. So previously, we would send out webhooks to, let's say, Shopee. And the moment the webhook is sent, it means that the money is owed. So clearly, we need to stop this process, right? We need to check before we let the marketplace know that delivery has been made. So here's our solution, webhook quarantine. So basically, if a delivery is deemed suspicious, we would quarantine the webhook for further manual checks. Yeah, so it's quite simple. The way you can do this is that if you have cash on delivery type, which is a large amount, above, let's say, $500, and the driver is new, for example, and the address is suspicious, for example, you can quarantine the webhook for further checks. Of course, what you want to do is you only want to quarantine the least amount of webhooks possible so that you inform the marketplace as quickly as possible about a delivery. Yeah. Okay, so here was how the system, an example of the system looked like before webhook quarantine. So you had a core service, like a driver service, which is publishing. It needs to inform the notification service to send out webhooks. So of course, in this kind of environment, it generally has to be asynchronous, right? Because you have millions of events happening at any point in time. So you publish a Kafka message, a notification server is going to consume this, and then eventually you're going to inform Shopee that, hey, your parcel has been delivered. Yeah, and then Shopee is going to notify the end customer. In this case, generally speaking, the delivery company does not have the details of the customers. We only can tell Lazada, Shopee, whatever. Okay, so here's the new system, webhook quarantine. So the way it works is that, as you can see, a new service has been introduced in between the core system and notifications. The way it works is that it receives the suspicious webhooks, and then it receives all webhooks, and then it decides if the webhook is suspicious based on configurable criteria. So for example, this driver is very new, he was previously flagged, this recipient is new, the parcel has a very suspicious weight. It's an iPhone, but it weighs 10 grams during our scanning. So these are all telltale signs that there's something wrong with this parcel. So based on that, these webhooks would be sent for further checks. And then if someone clears the webhook, they would publish, they would let a notification service know, and then the flow continues as well. So the notification system would now continue with the previous flow as well, and then you now know that your parcel has been delivered. So what was the impact of this? So the tool brought the instances of such fraud to zero. I'm not going to confirm or deny if they moved on to other frauds, but this type of fraud moved to zero when the crooks realized that they were not able to exploit this loophole anymore. So it was over $10 million that were protected in tandem with some other measures that were put in place. Okay, so I think we're a bit early, but I'm moving towards the wrap up now. So those were three real-life inspired examples of hacking at the workplace from my previous experiences. But why hack? So it's not about breaking things, right? It's about bending systems, quote unquote, to make them better. It's about being curious. It's about taking ownership. So you see a problem. You are a new engineer. You don't have a huge rapport of skills that you can use yet, but you know how to work with the Slack API. You had worked in a hackathon on this before. You're like, okay, you know what? This is something that I can kind of tackle. Surely there's a better way than going to a channel and notifying everyone at 4 a.m. of an issue, of which everyone is probably going to ignore you. So, and lastly, it's also about culture, right? So when people see senior leadership and even new members doing such things, right, what really happens is more people start to hack as well. So efficiency increases, innovation increases, you come up with cool ideas that you can work on. Okay, so why hack before you start a job? So I think I personally learned a lot from entering hackathons. Hack and Roll was one of them. as well. So quite thankful for that. But basically, it teaches you to see problems that others might be ignoring. There could be some elegant solution that you come up with. It's also how you learn faster than your environment. So what you eventually want to do, right, is you want to be not just a student, but a builder. You see a problem and you come up with a solution for it. So it's really about the agency aspect that I'm going for. Okay, so how can you start hacking at the workplace? Hopefully you guys are already, in university. Hopefully you guys are already doing this, but the way that I identified problems was, one thing is definitely automation, right? So there's a repetitive task that you're always doing. For every class that you're taking, you're creating a Telegram group, and then you're sharing the link with your classmates, and then you are doing these things. So maybe there is a better way to do it where you can automate the QR code generation and people can just scan it or something. It's a very contrived example. You can build a prototype over a weekend. You can share it. So I think one of the interesting things for me was some of the things that I worked on in university during hackathons did get some traction when other people were interested in continuing to work on it. And lastly, of course, keep curiosity alive. Okay, so like I mentioned earlier, I'm from NUS. I started hacking at NUS. Very thankful for the opportunities I was given. So some examples of things I actually built at NUS were, one of them was I used to stay in Cinnamon College, which I hear has been taken over by computing as well, so I guess it's good. But I used to be a USB student, and we were forced to subscribe to meal plans, right? So the way the meal plan works is that at the start of the semester, you basically pay for 2,000 meals, whether or not you eat it, right? And each meal costs you like $5 or $10. It's actually more expensive than eating at the food court for whatever reason. And guess what? There were certain patterns in the way that students were eating. So one example includes that all of us had the same class at 8 p.m. on Mondays, which means that at 7:30 p.m., right, everyone in the building was going to eat food. And on different days, there would be no one that shows up. So it's very difficult for the team to predict these trends. And what do? They just cook as much as possible for every single day because they don't exactly know these trends. So what I did is, I tried to understand the timetable trends of the USP students. Based on that, we predict how much food is going to be needed in a certain day. And then we give this list to the aunties who are cooking. So it's really a win for everyone. But sadly, I didn't see the food prices go down. So not sure about that. Yeah, so this was one of the things built during a hackathon as well. Second thing was an AR app to chope seats. So you guys know NUS Singapore is one of the safest places I can think of, probably in the entire world. When I was first joining NUS, I was surprised that people are using their laptop to chope seats. I was like, this probably doesn't happen anywhere else on the planet, like students are just leaving their laptops, their expensive MacBooks, whatever, walking away for 3 hours. The library has to like go and clear the laptops, right? But still no one fears it. They know that it's going to be at the lost and found and things like that. So I was like, there are so many tables that I can see in the library, in the classroom, but there's no easy way for me to tell whether it's taken because there's a flat device there. What if there was like a AR app in which I could see something hanging on top of tables? So basically the idea was I take out my phone and using the app, when I look, I can see a pin on tables that are choked. So that was the idea that I built during the hackathon and didn't do anything about it after, but maybe such a thing does exist now. Okay, lastly, ability to memorialize Facebook accounts into an online tombstone. Okay, I'm running out of time actually, but I'll make it very quick. So basically the way this one works, right, is that I felt that it's quite scary that if you were to suddenly pass away, if you go to your Facebook profile, it's going to be always there forever. So I was like, what if we can turn it into an online obituary of sorts where you remember the person who has passed away? So that was the idea that I pitched in a Facebook hackathon as well. But yeah, that's what I mean by memorialize. And if I'm not mistaken, it does exist on Facebook now. So they do have the ability for people to indicate that someone has passed away. Yeah. Okay, so very quickly, innovation isn't a department, hack responsibly, celebrate creativity, and have fun, most importantly. If you're not having fun, then something is wrong. All right, thank you very much, NUS Hackers, for inviting me and you, the audience, as well.